is to solve them. So we're going to be using the sine, cos, and tan, seen all them, and we're going to be looking at angle, elevation, and depression, and finding these angles, okay, and which is which. So let's say we go question one. See the type of questions come up. Let's say they ask us like construct a right-angled triangle containing angle A such that cos of A is 4/7. Okay, so they want us to draw a right-angled triangle, right? So we'll set it up. So let's say set it up here. Like this. Okay, and shine that up. Okay, trying to do a straighter one. Okay, so they're saying cos of A is 4/7. Okay, so this is 90 degrees. We'll go A is here, angle A. And they're saying cos of A is 4/7. So what is cos of A? Well, from our formula, cos of A is adjacent over hypotenuse. So what's adjacent to A? Well, this is adjacent, which will be 4. And my hypotenuse is always opposite 90, that's 7. Okay, and that's it. And then the second part of the question, from our angle, find sine of A in sort form. Okay, so what's sine of A? Well, sine of A would be x/7, but we'll have to get what x is. Okay, so if it's a right angle triangle, I have two sides. I want my third side, we can do Pythagoras. So that'll be the side squared plus the other side squared equals the hypotenuse squared. Okay, set it up. So that's x squared plus 16 equals 49. Okay, and then x squared equals 49 minus 16. So x squared equals, let's work that out, it's 33. So x equals the square root of 33. Okay, so we know that this is the square root of 33. And then they're asking, well, what is sine A? Well, sine A is its opposite over hypotenuse. You just need to know your formula for sine, which are in the log tables, but you need to know what sine opposite over hypotenuse. So what is opposite A? That's square root of 33 over 7. Right, so I don't know, does that break down anymore on a calculator? Let's see. Okay, so that's fine. You can leave in that form, I'd say, but if it breaks down more, break it down more. And that's in sort form. Right, so our next item is the angle, elevation, and depression. So we just need to know what it means. So you just need to know, well, basically the angle elevation is the bottom looking up, and the angle of depression is the top looking down. It's just gotta know which is which. So in a lot of questions, they'll tell you what the angle elevation and depression is, but they'll expect you to know, well, where is it? Now sometimes they give it in the diagram, sometimes they don't, but just be aware angle elevation is the bottom looking up. So you just gotta know the horizontal line is below here, and same with the angle, whereas the angle of depression, the horizontal line is above. So depression, top looking down, and the angle elevation is the bottom looking up. So we'll just go through an example of these questions. So let's say a tree 32 meters high, casts a shadow of 63 meters long. Calculate theta, the angle of elevation. Okay, so they're telling us theta is the angle of elevation, and they want us to find it. Okay, so we know, okay, they tell us the tree is 32 meters high. So that's the height of the tree. So that's 32 here. Okay, so really we're looking for this side here, up to the tree. Okay, the straight line there, height of the tree. Okay, so how will I get the theta? Well, I need to know what is 32 to theta is opposite. Again, we're going to use one of our rules. It's opposite. And what is 63 to theta? It's adjacent. So you need to know what is opposite over adjacent. Formula, well, that'll be tan. So tan theta is opposite over adjacent. So that'll be 32 over 63. Okay, but I need to know what angle gives me that. So we can work that out in the calculator. So again, it'll be invert. I'm looking for my angle, so it'll be the tan inverse function. Okay, so it'll be this -1. Okay, so what is 32 divided by 63 if you don't want to work that out first? Okay, so that'll be 0.5079, or you can just do one go on a calculator. So second function tan 2 over 63, and that'll be 26. Asking us to round it up to the nearest degree. Okay, 26.9 degrees. Okay. Okay, so it's nearly 27 degrees. Okay, so they're saying to the nearest minute. Well, we know that 60 minutes in a degree, so you can do 60 multiplied by 0.93, and that'll be 56. Or okay, so 26 degrees. That's 56 minutes if you want to round it up. Okay, that's fine. Now, next one is a man standing on a cliff sees a boat at an angle of depression of 34 degrees. If the cliff is 50 meters tall, how far from the cliff is the boat? Okay, so we fill in always what we know. So what is the angle of depression? Well, they're telling us fill it in here, but always the horizontal is above it. So this has to be 34. Okay, that's 34. This has to be 90. Right? So this angle, all this 34 plus this angle has to add up to 90. So the difference has to be 90 minus 34. So this has to be 56 inside the triangle. Okay. Let me just write that in. It's a 4. I guess I'm not sure. This is a 34, but I know that the 34 and 56 adds up to 90. Okay, and I know the height of the cliff is 50. Right, and what they're asking us is how far is the boat from the cliff? Okay, so we need to know, we're looking for this distance here. Okay, so we're looking for what we call x. How far is the boat from the cliff? Right, so again, I would say what is x to 56? Would that be opposite? And what is 50 to 56? Well, that's adjacent. So it'll be, what is opposite over adjacent? Well, it'll be 10. So 10 56 equals x over 50. Okay, and obviously we're solving for x. Now, 1056 is really over 1. So now if something over something equals something over something, just cross multiply. So x by 1 will be x. and then I 50, 10, 56. So we'll just fix that up. So that means x equals, now I'll put the 50 before the 10 because some students will go 10, 56 multiplied by 50, but that means you're just multiplying the degrees by 50. It just kind of messes it all up. So just getting a good habit, put the number first. Like it's 50 multiplied by 1056. 1056 stays together. So, okay, so x equals, okay, out the calculator, calculator on degrees, 50 multiplied by 1056. Okay, and they're asking us to round, okay, so 74.1, we'll say round it, 3 meters. Okay, that's how far the boat is from the cliff. Okay, so angle elevation, angle depression question. You just got to know angle depression, top looking down, angle elevation, bottom looking up. Right. So our next one here is, they're given the diagram. Like, I tend to give stories, but I won't get too bogged down by the stories. Like, in the day, you'll be looking for a side or an angle. Okay, so they have it all drawn up for you. They want you to get 10 of x. Okay, write down the value of 10 of x and find the value of x. Okay, so 10 of x has to be, well, it has to be 5 over 4. Put it in here. And then they want to know, well, what angle will that come to? Well, it'll be just second function 10, 5 over 4 in the calculator. Correct the two decimal places. Okay, so that will be 51.34. Okay. Oh yeah, that'll be down here. Sorry, the angle x is 51.34. Just fix that up. Let's answer the second one and the first one. Okay, degrees. Right. Okay, so now they're saying they're in order to increase the height of the swing side to increase x by 20%, and angle AB is the same, and find the height of the new swing. Okay, so we'll just do a rough sketch here. Right. So they wanted to find the height of the swing, so that we call that h. Okay, so 51.34. Make that 20% bigger. So get 20% of it and add it on, or just multiply by 1.2. So it'll be 61, let's say 0.6. And the distance AB is staying the same. Okay, I actually have to get AB, right? I didn't think I had to, but I will. Okay, so given that that's a 5, that's a 4, I can use Pythagoras because that's 90. So we'll call it AB squared. So this is a Pythagoras. AB squared equals 5 squared plus 4 squared. That's the squared hypotenuse equals the sum on the other two sides. So it's basically our side squared plus side squared equals hypotenuse squared. So that'll equal 25 plus 16. Okay, so we'll work that out. So that'll be 41. So AB squared is 41. So what's AB? Well, AB has to be the square root of 41. Okay. Again, I just leave it square root of 41 because it's going to be a decimal. You can leave it in short form. So this is going to be the square root of 41. Okay. And now I'm looking for my height. So I have my angle. I know that H is opposite. Okay, H stands for height now, just clarify that. So it'll be sine, so we'll just do it here. So sine 61.6 is opposite over hypotenuse. That's my H over square root of 41. Okay, again, look for H, that's obviously over 1. Again, something over something equals something over something, always cross multiply. So H equals root 41 sine 61.6. Okay, and we work it out all in the one calculator. Sine 61.6 multiplied the square root of 41. Okay, so we'll just double check that. Was it over hypotenuse? Okay, so by root 41. So we get our height 5 point, what did I say, into one decimal place, 5.61. Okay. And multiply square root of 41, just double check it. 5.162 decimal 3, I'd say. Okay. And that's our height. Okay, so just watch it on the calculator there. Right. Our next one, working with a cliometer. Them type of questions come up again. Just show them. It's just when you're measuring how it works. So that's why I just gave this one. So they're asking us about the hotel in Dubai. Okay, again, bit of information. I wouldn't get too bogged down by the story. Okay, so 268 from the beach. A tour standing on the beach who is 1.6 meters tall. Found using a climometer that the angle elevation to top is 50 degrees. Okay, so draw a suitable diagram of the height hotel to the nearest meter. All right, so again, we'll just set it up here. Right. So what we have is a person standing. Okay, so pace climate is an instrument to measure angles. Okay, so let's go here. Right, and so that's with his vision. So he's looking from there, and basically this will be 90 degrees. No. Okay, so we want the height of the hotel. Okay, so he is standing 268 from on the beach. So he's 268 here. So where he is. Right. This angle from his line of vision is 50 degrees, which is telling us. Okay, we're looking for the height of the hotel. So from here, we'll call that H, but we know his height, he's 1.65. Okay. Right. So we need to calculate the height of the hotel. So we'll just work with, like, if this is 268, okay, this here is 268 from where he's standing. So it'll be 10 10 and 50 equals opposite over adjacent. Okay, so we go for H now. Again, cross multiply. So H equals 268 multiplied by 10 and 50. So that'll give our height. So let's work out in the calculator. So that'll be 319. Point 39 meters. Okay, right. But see, that's the height of H, as in from here to here. But what we got was that height, but we need the height hotel, so we have to add on the 165, his height. We just got the height from here to here, but don't forget his height. It's the 1.65. So the hotel's height, we'll call the final answer. We'll work that out. So we're saying, right, just not to confuse, H is here, but we want the overall height, so we have to add on the 165 as well to the nearest meter. So that'll be 321 meters. Okay. So just watch that with the clinometer, or that means just it just means you have to factor in the person's height as well. Okay, so we'll get another one. So they're giving us another story, angle elevation. They're telling us it's 23 degrees. Okay, 764, and they want us to find x. Okay, so again, what is 764 to 23? Opposite. What is x? That's my hypotenuse. So that has to be sine. So it's just sine of 23 equals 764 over h. Okay, and again, cross multiply. So basically h sine 764 h equals 764 divided by sine 23. Okay, that's all. Okay, so we worked out in the calculator. Divided by sine 23. So to one decimal place, so 1955.3. Okay, so that'll be the hypotenuse. Then suggest one possible source of error that may affect Mark's calculation. Okay, so this kind of just an Englishy question. So basically, just clinometers, there is a margin of error, just a small, but they can be a bit out. Okay, so some clinometers, like, they're not the most 100% accurate. You could just say that. has a margin of error, we'll say. So it just means you can be a small bit out, a degree or two. Okay, that's that one done. That type of question. Okay, so the next one, again, bit of a story. They were drawn for you. We got our lint. Okay, so we need to get the angle. Okay, the ladder is safe when the angle marked y is 75. Is it safe to use the ladders? Okay, so we need to get y. So again, what is 70 to y? Well, that's adjacent. And what is 2 to 5? Well, that's hypotenuse. So it's going to be cos of y equals 70 over 225. I just worked out in the calculator. You get the inverse function. So we're getting, what is y? I'm getting 71.87. Okay. So it has to be 75 degrees, therefore not safe. It's less. I'll just say that. Yeah, that's it. Straightforward as that. We get our angle. They give a bit of a story. We don't be put off by it. Okay. So what is the height of the ladder? What is the height the ladder can reach up the wall when it's in a safe position? Okay, so sketch there. Right. So what height can it reach? Well, you only can reach it when it's 70, so we'll just or 75 degrees. So that has to be 75. Again, this here is this is the ladder 225, so that'll always be 225. And then my height that it can reach, well, this will be x. Okay, so again, what will that formula be? What is x to 75 opposite over hypotenuse? So it'll be sine 75 equals x over 225. Okay, and again, back to our sine constant. Something over something equals something over something. You cross multiply. So x equals 225 sine 75. Let's work that out in the calculator. Again, make sure it's on degrees. So our height has to be 217.3 meters. 0.3 centimeters, sorry. That's our final answer. Okay, so let's just work in the sine cos and tan. As long as you know your rules or Pythagoras, you know, and they give a bit of story, but don't be put off by it. Just what am I looking for? Side angle, and just work it out. And we did the clinometer, just watch that, what it is, and the angle, elevation, depression. You just need to know which is which. Okay, so they were just all the trigonometry kind of questions that come up. That concludes today's lesson.